Hello grade 9 students, this is a version 2 power study on geometric mean. So in this lesson, we will be discussing about geometric mean, and we're going to also identify similar right triangles, right triangle geometric mean theorems, and then we're going to use geometric mean with right triangles, and we're going to use geometric mean in real world example. Okay, solve the proportion. Okay, this is just a review. 13 over 6 equals x over 8. Meron ng answer which is C. 52 over 3. How did you get it? By cross products. Diba? 6x equal to 13 times 8. 13 times 8 is yan, 104. 104 over 6 is 52 thirds. Yan, lowest term niya. The triangles to the right are similar. Find x and y. Yan, use proportion here. X is to 11.7 equals 5.6 is to 4.2. Okay, by that you can be able to solve for x. Pag y naman, 2.8 is to y is equal to 5.6 is to 4.2. So you come up with your answer as letter C again. So x is 7.8, y is equal to 8.4. Did you get the same answer? I hope so. Okay, determine whether the triangles are similar. If so, write the similarity statement. So triangle ABC, triangle DEF. Tapos may mga sides doon, 2.8, 1.7 for triangle DEF, 2.72, 4.48 for triangle ABC. Okay, just try to see if the sides are proportional. 2.72 divided by 1.7, is it the same as 4.48 divided by 2.8? Okay, the answer is C, yes. Triangle ABC is similar to triangle EFD. Yes, because the sides are proportional. Next, find the perimeter of triangle DEF. If triangle ABC is similar to triangle DEF, AB is 6.3, D is 15.75, and the perimeter of triangle ABC is 26.25. And it will be your equation. Okay, proportional lang naman yan. What's your answer? Answer is 66.25. 6.3 over 15.75 is equal to... Wait. 6.3 over 15.75 is equal to... Yan, 26.5 over x. So from that, you can be able to solve for the perimeter of triangle IDF. Okay. Number 5. Feature JKLM has perimeter of 56 units. After the relation with a scale of factor 2, what will the perimeter of feature JK, J prime, K prime, L prime, M prime be? The answer is 112 units. Yan, times 2. So in this lesson, we're going to prove theorems about triangles, use congruence and similarity criteria for triangles to solve problems, and to prove relationships in geometric features. And for mathematical practices, look for and make use of structure, construct viable arguments, and critique the reasoning of others. In the previous lesson, we use proportional relationships of corresponding angle bisectors, altitudes, and medians of similar triangles. Now we're going to find the geometric mean between two numbers and solve problems involving relationship between parts of a right triangle and the altitude to its hypotenuse. Okay, new vocabulary. Geometric mean. What is the geometric mean? The geometric mean of two positive numbers a and b is the number x, such that a over x equal to x over b, so x squared equals ab, or in short, x is equal to square root of ab. Yan ang geometric mean. Example, what is the geometric mean of a equals 9 and b equals 4 is 6, because Square root of 9 times 4 is 36. 36 square root of 36 is 6. Yan. Now, find the geometric mean between 2 and 50. 2 times, square root of 2 times 50 lang yan. Answer yan. Square root of 2 times 50, square root of 100 is 10. Diba? Yan. Yan, pag long method. The geometric mean is 10. Pag long method using proportion, excuse me, medyo pangit yung throat ko ngayon. Can be muna ako. So, pag long method ito, 2 over x equals x over 50 ang equation niya. Then cross products, x squared equals 100. Get the square root of both sides, positive square root, x equals square root of 100, x equals to 10. So, geometric mean is 10. Pero pag shortcut, square root of 2 times 50 lang yan. So, square root of 100 is 10. Find the geometric mean of 3 and 12. Square root of 3 times 12 is 36. Square root of 36 is 6. So your answer is B. Theorem. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Example. If CD is the altitude to the hypotenuse AB, here, right triangle ABC, then triangle ACD is similar to triangle ABC. Triangle CBD is similar to triangle ABC. Triangle ACD is similar to triangle CBD. So if you're going to draw an altitude to the hypotenuse here in triangle ABC, you can form 3 similar triangles. They are similar, okay, to each other. Tatlo. So identify similar triangles. Write the similarity statement identifying the 3 similar triangles in the figure. So separate the triangles into 2 triangles along the altitude. Then sketch the 3 triangles, reorienting the smaller ones so that their corresponding angles and sides are in the same position as the original triangle. That will be the 3 triangles formed from the original triangle EFG. Yeah. Drawing ka dyan ng altitude. So, H dyan. So, dito na yung nabuo. FHG and EHF. Triangle EHF. These are all 3 right triangles and they are similar with each other. So, by Theorem 8.1, triangle EGF is similar to triangle FGH, similar to triangle EFH. Write a similarity statement identifying the 3 similar triangles in the figure. Okay, triangle LMN. MO is the altitude to the hypotenuse, LN. So what are the 3 similar triangles in the figure? Answer is C. Triangle LMN is similar to triangle LOM, similar to triangle MON. Yan. Right triangle geometric mean theorems. Geometric mean theorem, the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into 2 segments. The length of this altitude is the geometric mean between the lengths of these 2 segments. Example, if CD is the altitude to the hypotenuse AB of right triangle ABC, then x over h is equal to h over y, or in short, h is equal to x square root of xy. Yan, ito tinatawag na geometric mean altitude theorem. Yan. So for h, just get the product of the square root of the product of x and y. Ito naman tayo sa geometric mean leg theorem. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into 2 segments. The length of a leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to the length. So I've discussed this in version 1. Example, CD is the altitude to the hypotenuse AB, right triangle at ABC. Then C over B is equal to B over X, or B is equal to the square root of XC, and C over A is equal to A over Y, or A is equal to square root of YC. So So, in short, pag h, square root of xy. Pag b, we want to solve for b, square root of x times x plus y. We want to solve for a, is equal to square root of y times x plus y. Ganun naman. Ganun lang. Yan. Find C, D, and E. Okay. JM is 6, ML is 24. Find E. Okay, that's easy. If you want to solve for E, just get the square root of 6 times 24. Yeah, 6 times 24 is 244. So therefore, E is equal to 12. Yeah. Going back. So, E is 12. We want to solve for D. It's equal to 6 times 24 plus 6, 30. 6 times 30. Square root of 6 times 30. Yan. Yeah, square root of 180. We want to solve for C naman. It's equal to square root of 24 times 30. Yeah. Ano lang. Want to solve for E, square root of 6 times 24. We want to solve for D, square root of 6 times 30. You just add this, 6 and 24. If you want to solve for C, it's equal to 24 times 30. So E is 12. How about D? Yun, 6 plus 24. Square root of 180 or 13.4. If you want to solve for C, 24 times 30 naman. It's square root of 720 or about 26.8 using your calculator to simplify. So E is 12, D is 13.4, C is 26.8. Find E to the nearest tenth. Saan yung E? Ay, ito. Dali lang. Solve for E is equal to 16. Square root of 16 times 20. 16 times 20 is 320. Square root of 320 is 17.9. Using your calculator. Okay, ito na word problems na tayo. Applying the geometric mean theorem. Miss Alspach is constructing a kite for her son. She has to arrange 2 support rods so that they are perpendicular. The shorter rod is 27 inches. The long. If she has to place the short rod 7.25 inches from one end to the long rod in order to form 2 right triangles with the kite fabric, what is the length of the long rod? Okay. Sorry for that. The feature involved is kite. So let's try to draw a diagram of one of the right triangles formed. So 13 YX 13.5 inches, WX 7.25 inches. Let YX be the altitude drawn from the right angle of the triangle W. WYZ. So ang hinahanap natin dito, the length of the long rod. So solve for this, our equation will be applying the geometric mean altitude theorem. So 13.5 is equal to square root of 7.25 times XA. Ano ba yung XA? XA yun. So square each side. 182.25 is equal to 7.25 XA. Divide both sides by 7.25. Therefore, XA is 25.14. So the length of the long rod is 7.25 plus 25.14, or that's about 32.39 inches long. Okay. So we have solved the kite problem applying the geometric mean altitude theorem. Okay. A jetliner, another problem on airplanes. A jetliner has a wingspan BD, okay, of 211 feet. The segment drawn from the front of the plane to the tail AC intersects BD at point E. If AE is 163 feet, okay, what is the length of the aircraft to the nearest tenth of a foot? Yeah, 211 divided by 2. So BE is 1/2 of 211 yan. Plus 163 yan. So solve mo dito yung EC. add to 163, yun yung sum ng, yun yung the length of aircraft with the nearest 10 foot. And the answer is 231 feet. 231.3 feet. So that ends our lesson on geometric mean. This is version 2. So again, I'll see you next time. Thank you for listening. Bye.